All right, in this video we're going to talk about some of the special factoring formulas that we have for factoring certain specific types of expressions. Now some of these relate to the special product formulas, which I did a video about some special product formulas a while back. So a couple of these relate directly to those special product formulas. Right, and just like those special product formulas, some of these are important to know, some of them are not so important to know. Right, the first one we have up here, which is the difference of squares formula, is really important to know. Right, so that one, if you have an expression of the form a squared minus b squared, right, we call that a difference of squares because it's a difference, right, a subtraction of two perfect squares. Right, so it might be something like x squared minus 4, right, where x squared obviously is x squared and 4 is 2 squared. So something like that would be a difference of squares, and you can factor that into a minus b times a plus b. Right, so you take basically the square root of each one of those terms, and you make two factors with those, and one of those factors gets a minus in the middle, the other one gets a plus in the middle. Right, so that is how you factor a difference of squares. And I'll be doing another video after this one where I do a bunch of examples, or a few examples at least, of using some of these formulas. So I'll show you some examples of those in the next video that I do. Right, but that's just the difference of squares formula. The next two are two perfect square formulas, and notice I put like x's over the numbers of these. These are the ones that are not so important for you to memorize. Right, so if you have something of the form a squared plus 2ab plus b squared, that factors into a plus b squared. Right, that's why they call it a perfect square, because this whole thing is actually one quantity being squared. And if it's an a squared minus 2ab plus b squared, that factors into a minus b squared. Right, so the problem I have with these formulas, there's nothing wrong with the formulas themselves, but the reason I say that they're not that important to use is because a lot of times they're really hard to identify when to use it. Like if you're not specifically told to use a special factoring formula, if you're just given, some trinomial expression with three terms, you might not notice that it's in the form a squared plus 2ab plus b squared. Right? You might not even realize that it's in this form, that you can use this formula. And even if you do realize that and you do remember the formula, you can always factor these just like you would factor any other trinomial. Right? I did a couple of videos about factoring trinomials when it's like a 1x squared, or if there's another number times the x squared. So if you just follow those methods to factor one of these, you'll get the correct answer. You'll just notice, oh, my two parentheses happen to be exactly the same. Right? This one's x plus 3 times x plus 3. Oh, that's x plus 3 squared. This was one of those perfect square trinomials. I didn't even notice it, but even if you don't notice, like I said, you can still get the correct answer. Right, so the perfect square ones, now as far as formulas you need to know, I would say those are less important than the other ones that are up here. Right, difference of squares, the first one up top, super important. The last two up here, the difference of cubes and the sum of cubes, are fairly important. They're important in the sense that if you don't know what the formula is and you're faced with one of these things that you need to factor, you're going to be really hard pressed to figure it out if you don't know the formula. Right, like I said, for these ones up here, if you don't know the formula, you can still just do the trinomial factor and you'll get the right answer. That's probably not going to work with these sum and difference of cubes. Right, so they're important in that respect, that when you have to factor one of these, you need to know the formula to factor it. But these don't come up that often. Right, the difference of squares up here, you kind of see that a lot as you go through algebra and pre-calculus and calculus. That comes up a lot of the time. The difference of cubes and the sum of cubes, you'll see once in a while, but it's not one of those things like you're using this formula every day or every week. It doesn't come up that often. But again, when it does come up, you kind of need to know what it is. So the difference of cubes, the sum of cubes formula, they're very similar. A cubed minus b cubed, a cubed plus b cubed, right? So one's the difference with a minus, one is the sum with the plus. And the formulas of what those are equal to are also very similar to each other. Right? So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. Right? So it's basically the cube root of each of these original terms, a minus b, and you keep the same sign. And as far as like the signs, the pluses and minuses, there's a little thing we can use to remember that called SOAP. I know you know what SOAP is. Hopefully you know what SOAP is. But SOAP, S-O-A-P, stands for same, opposite, always positive, or always plus. Right? So whatever this sign is, the first one you put in here is the same. So if this is a minus, that's a minus. If this is a plus, this is a plus. Right? The other parts, the a and the b, are exactly the same between these two formulas. Right? The other stuff is also the same, the a squared, the ab, the b squared. What's different is a couple of the signs, the pluses and minuses. Right? So this SOAP thing helps you remember where to put the plus and minus. Right? So the first one is always the same as what you started with. The second one is always the opposite. So the next plus or minus you see, the one in here, is the opposite of the original one. So if this is a minus, this over here is a plus. If this is a plus, this over here is a minus. Right? So that one's the opposite. And then the last one that you see is always plus. Right? So that's a plus b squared, that's a plus b squared. Right? So same, right? The same, then the opposite, and then always a plus. Right? And the same and opposite refer to the original sign that you had in your original expression. All right, so those are our formulas for the sum and difference of cubes. And like I said, I'll be doing another video after this where I do an example of a sum or a difference of cubes. I don't know which one I'm going to do, but I'll do at least one of those. And when I do that one with the example, I'll show you kind of a little trick to help you remember what that formula is. That'll make it a little bit easier. Rather than memorizing the formula, there's like a pattern to it that if you see the pattern, it helps. And since I'm talking about it, I might as well mention it here. So, right, we have the a cubed plus b cubed. So the first parentheses is just the cube root of each of those with that same sign, right? So just a plus b. The second parentheses is when you start with this first parentheses, you multiply a times a, right? That gives you a squared. You multiply a times b, that's your ab, with the opposite sign of what you had here. And then the last thing is b times b to get your b squared, and that b squared is always a plus, right? So it's, again, the cube root of each of these, a plus b, and then it's a times a, right? A times b, and then b times b. And then that's how you can fill out that second parentheses. And like I said, I'll do that in an example with some actual numbers and variables and stuff in the next video that I do. So check that one out to see it. All right, so we have the sum and difference of cubes formulas. We have the difference of squares formula. Notice there's not a formula for the sum of squares, right? So a sum of squares would be something like this, right? A squared plus b squared. Right? If you have a sum of squares, so like for example, what I said before, like x squared minus 4 would be a difference of squares, and you can factor that. If you had x squared plus 4, that cannot be factored. Right? There's no way to write x squared plus 4 as two things multiplied together. They're going to give you x squared plus 4. Right? When my math teacher told me that back when I first learned algebra in high school, they're like, oh, you can't factor a sum of squares. I wasted like an entire afternoon trying to figure out how to do it. I couldn't figure it out. So my math teacher wasn't lying, right? You can't really do that. So when you see a sum of squares, you just can't factor it. That's what we call prime. But a difference of squares can be factored. When it's cubes, a sum or difference of cubes, either one of those can be factored, but not a sum of squares. All right, so those are some of our special factoring formulas. And like I said, I'll do another video where I go through a couple examples of some of those to kind of show you how it works when you actually use those formulas. So make sure you check out that video.